Hi, this is Professor Fernandez working on Class Note C in Lesson 10. The point of this class note is to show you how to visualize vectors. So that's what we are going to do. If you have taken a physics course or perhaps an upper level chemistry course, or you've taken some other math courses where you've talked about vectors, then you've seen this before. Obviously, if you haven't, it's totally okay. But in other words, I say that because I'm making connections to other subjects you might have already studied. In our class so far, we have been talking about a vector as an n by 1 matrix, right? So something that looks like that. So to visualize them, I'm just going to look at vectors in the plane. So vectors with two components, let's say x and y. All right, so I'm kind of already foreshadowing what you might expect when you think of x and y. So I'm going to draw the Cartesian plane. Here we go. And I'm putting this to denote the axes themselves, not the actual values of the vector. So actually, to not confuse anyone, because I can see that happening, let me change this to A and B for the components. Okay, so one thing that you could immediately do, right, is you could plot the point AB in the plane. So the vector x, a reasonable way you might want to visualize it is to say, well, the x component is A and the y component is B. Okay, fine. But that kind of doesn't distinguish it from this point AB that's kind of just floating there, right? So the way that we visualize vectors in the plane, and really, in any dimension, is we start at the origin, and then we draw an arrow and stop at the point that corresponds to the coordinates of the vector, the components of the vector, in this case AB. Okay, so a couple of examples here. So if I want to visualize the vector, let's call it x of 1 equals 1, 1, then I would add some actual numbers here, and that's my vector 1, 1. If I want to visualize the vector, let's say 2, 3, then I would go 2 units to the right and then 3 units up, and I would draw my vector that way. Okay, so that's the vector x2. I'll do one more to illustrate a point. So what if I want to visualize the vector negative 1, negative 1? Okay, so then I would go 1 unit to the left, x component, and then 1 unit down, negative 1. And then put a point where I end up, and then draw an arrow from the origin to there. Okay, so this is very quickly how you visualize vectors. Let me talk a little bit about the axioms, the vector space axioms that you studied right above this page. So, and show you how you visualize some of those. All right, so with the vectors that I have just illustrated over here, let's talk about addition. All right, so let's take this vector x1 up here, and let's take this vector x2 over here, and let's see how I would visualize their sum. All right, so down here I'm going to calculate x1 plus x2. We already know how to do this based off the work that we did in this lesson for how to add matrices. And what we said was, first of all, the matrices have to have the same size. These do. They're both 2 by 1 matrices. And then if they do, then we just add the components together. So this is going to be 1 plus 2 and 1 plus 3. So that gives us 3, 4. Great. So that is the sum of vectors x1 and x2. So if I were to draw this as a visualization now, so let me remove some of the clutter from this graph. Right? So what if I want to visualize this sum? So I'm going to leave those two vectors up. Well, it is the vector with x component 3 and y component 4. Okay? So I'm going to go back here and go 3 in the x direction and 4 in the y direction, and I get this vector up here. Right? So, my drawings are not perfect, but you can see that this vector is longer than the other two. And it's a vector that somehow must be related to x1 and x2, right? That's how it arose. So the question is, visually, how would you get this vector? Well, this is the way that we have come to understand how we add vectors in this visual way. What do we do? So we would start down here at the vector x1. Okay, so that's this blue vector that we drew over here. Okay, and then we are literally down here adding x2. So thus far, I've been showing you vectors starting at the origin and going off to the point that corresponds to their components. If we're adding the vector x2, then we could start at the end of x1 and then take this vector x2 that we already have and just kind of like move it over a little bit this way so that the vector x2 starts from the end of x1 and goes however long this vector normally goes, right? This is called translation in the plane. So if I draw an arrow here, I can kind of translate it that way to this arrow. Or I can then translate it maybe over here to this arrow, right? So that's what we're doing here, right? So what do we get? Well, if I take this picture and again declutter it, I'm going to get rid of this green stuff as much as I can. There we go. Then this is what emerges, right? So what we see that down here, if I want to understand the sum of x1, vector x1, with vector x2, then I just put the tail of x2 at the head of x1. And then I would draw the vector that goes from the origin to the head of x2, right? And that vector is x1 plus x2. Okay, so that's how we would add vectors as an example. Let me go back to, so this is the first thing I'll illustrate. I'll illustrate two more things. The second one is illustrating scaling vectors, right? So this first one is useful for illustrating the first vector space axiom, which involves adding and subtracting vectors. This next one is going to be useful for illustrating the second vector space axiom, which involves multiplying a vector by a number. So let me go back to my vector x1, which is 1, 1. And what if I multiply this vector, let's say by 2, forming 2x? Again, we have definitions for how to do this in this lesson, in the video that we that preceded, the two videos that preceded this one. So what do? By definition, I multiply 2 into every component of the vector x1. So I get 2, 2. Okay, so if I were to draw this out, I originally had my vector x1, which had 1, 1 as its components. And now I have my, oops, I should have put that in red. Let me do that. My original vector x1, 1, 1. Okay, and now I have a vector x2, which has components 2, 2. So I'm trying very hard to draw what I think you've picked up on, which is that, you know, x1 is twice as long as x2. We haven't talked about the length of vectors yet, but I'm just giving you a visual for how you can explain this. Let me do one more calculation. So what if I did minus x1? And then this is very closely related to what we did up there earlier in this in this example. So I multiply -1 times every component of the vector, -1 times 1, -1 times 1, and I get -1, -1. All right, so then that means that I go to the left 1 unit, and I also go down 1 unit. All right, and then what would I get here? So I just go down this way, and I would finish at the point -1, -1. So again, I've tried really hard to illustrate that, you know, a fact, which is that if you multiply a vector by a negative, it literally negates every component, right? So you get a reflection about the origin. Okay, so with all that said, what am I going to do now? Well, let's illustrate how we subtract vectors. So what if I went back to my example here of x1 and x2 up here, right? What if I wanted to subtract them? All right, so I'm going to erase what's going on here and then try to subtract x1 and x2. So how would I do that? Well, the first thing I want to show you is how to think about it, and then we will illustrate it. Okay, so if I want to subtract, let's say I want to subtract x1 minus x2. Notice that this is the same thing as x1 plus negative x2. All right, and that's really the way that's going to allow us to visualize it, because we just talked about what happens when you multiply a vector times -1, and we just talked earlier about how you add two vectors. So I'm going to first calculate x1 minus x2, and then we can plot the result and understand how to visualize it using the concepts we just discussed. So if I calculate this, again, there are two matrices. They have the same size. I'm subtracting them. So I just subtract their components. So I get -1 and -2. Great. So now let me go through and see if I can plot these two vectors. So the first one that I'm going to plot here is x1, and that's the vector that goes to 1, 1. So 1, 1, that's the x1 component. Great. And then I'm going to plot the vector -x2. So let's do that in red. So that's the vector over here. You can see it that has components -2, -2, and -3. 1, 2, 3. So it's kind of hard to plot it, but it's down there. Okay, so that's that vector. And then what's the vector I've obtained? Like -1, 2. So I'm sort of running out of colors here. So I'll put that -1 and then -2 down here. That's down here. Okay. So this doesn't look like it makes a lot of sense, but now let's interpret it in this way. All right, so let's start with x1. There we are. And then let's add -x2. Okay, so remember how we said that we were going to do that from the previous minute or so explanation. I would start at x1, so I go from the origin to x1. Okay, and then when I reach that point, I am now going to draw the vector -x2, which is this red one down here. Okay, so I'm going to draw that vector starting at the origin. I'm just going to take that red vector and try to move it this way to this point. So you can see how I'm going to end up over here where the green vector x1 minus x2 is. All right. So that's just a quick little rundown of how you visualize drawing vectors, right? So we draw them from the origin to the points that corresponds to its components. Adding vectors, so we do this translation of starting with the first vector and then continuing with the second vector and then completing from the origin to the point that that results from that sum. Scaling vectors, right? So you just literally multiply the vector by a number. Well, that scales it like we did in earlier examples. But if it's negative, then that flips it about the origin. And then subtracting vectors, right? So when I subtract vectors, the same as adding the negative of the second vector. So I can, again, combine that scaling and what we just talked about with the translating to visualize that.